Hi, and welcome to BH Sensor's pressure sensor demonstration. In this demonstration, we couple our patented core non-contact sensing technology with a simple brass diaphragm to realize a pressure sensor that can measure a 36-inch water column to a repeatable accuracy of 1 part in 10,000. The sensor is constructed of a PC board housing the sensor electronics and a brass diaphragm soldered to the PC board at a fixed height above the sensing element. As water is pumped into the column, the rising water creates pressure on the diaphragm, causing it to deflect at its center. A sensor measures this deflection and reports the pressure to the microcontroller located in the foreground. The fill and discharge cycle is controlled by arbitrarily chosen pressure threshold points. The amount of water in the column is solely controlled by the pressure sensor's measurement. Now let's look at the system in action. The inset graph shows the pressure buildup versus time as the column fills with water from the pump. Notice as the column fills, the pressure curve versus time is not linear. This is due to the fact that as the column fills, the water exerts a back pressure on the pump due to the hydrostatic height of the water, so that the pump now must work harder to add more water to the column. The result is that, per unit time, less and less water is added to the column, and hence less pressure is built up per unit time as the column fills. And we can see that as the column fills further and further, the pressure versus time approaches an asymptotic curve. The nonlinear pressure versus time that we see here is not the case once the threshold pressure is achieved and the pump is turned off. Once the pump is off, the water drains out of the column due to gravity, and the pressure drops versus time is completely linear, as you can see here. Now, watch what happens as we approach the bottom. Notice that when the pressure drops to such a level that 1/2 the diaphragm is uncovered, that threshold pressure level causes the pump to turn back on. This pressure corresponds to 1/2 inch water column, or a low pressure of approximately 0.02 psi. And of course, now the cycle begins again. We chose a water column measurement for demonstration because traditionally, low pressure measurements have been difficult to achieve without resorting to large diameter and ultra-thin diaphragms. Not so in our case, where the diaphragm is a comfortable 1 inch in diameter. Keep in mind that we could have easily substituted a different diaphragm of either size or material and could have created a 1000 psi pressure sensor using the identical sensing technology, electronics, and PC board that you see in this video without the need to change any of the electronics. That's about it. Thanks for watching. See you next time.